Testing one, two. Good afternoon. Up next. We have Atash to talk about catching up trends in audio app development. Let's welcome Atash.
Thank you for coming to my talk. Okay, this is a talk about catching up trends in audio app development, which would be kind of fun. And all my slides are available already on speakerdeck.com/@shen, so please find it. I also added a note on the HackMD, so you don't have to add it. So what is this? And audio app development world is fun and hard. Anyone tried to build some audio application before? Oh my god, that's great. I expected like one or two or so. That's so many. Okay, I guess we rarely see this kind of technical session talk at COSCUP, but it seems like there's actually a few of those. But anyhow, I'm giving it a try. So what can be an audio topics here? And it can be many, but and I named a few of those, but not limited to these. But first of all, there are tools like music creative tools like DAWs, digital audio workstations, and synthesizers and effectors that could be used for creating music. And technology like MIDI or 3D audio in AR and VR, and musicology or analysis stuff like analyzing some music in theory and passing existing music into some numbers, or voice synthesis technologies, also technology in general. And DSPs, algorithms, and mathematics, and tools for those such as MATLAB are also topics that audio developers deal with. And programming text to audio, such as in C++, especially in C++ standards, and real-time safety in C++ is a hot topic as well. And lastly, audio plugin development, such as OVST or audio unit, or elevator clap, and area, or some libraries to make it possible, like Juice or DPF or whatsoever. They are also audio plugin, audio topic as well. And recently, on the web or using AI or in Rust are all popular topics these years. And then what are the hot topics in these years that I'm going to mention today? There would be many, still many, but I only have 30 minutes. So I listed only 5 items, and if I use 5 minutes for all, it's already 25 minutes. It's going to be superficial, so excuse me of that. But anyhow, the first thing I want to mention is real-time processing in C++, and it's part of a hot topic and a classic topic, and we have been discussing it forever, so it's still a hot topic. And AI utilization is apparently a hot topic, and not limited to audio. It's a hot topic everywhere. And recent interesting thing is use of web views in audio apps and audio plugins. I will describe that later. And changes in plugin development trends, like we have been using some cross-platform libraries called Juice, but it's gonna kind of changing. And I mean, it's still popular, but some people are trying to change it. So it's interesting. And lastly, MIDI 2 adoption is moderately ongoing. There are many technical sessions about MIDI 2, and it is not really adopted yet. Anyhow, let me dive into each topic. First thing is audio and real-time safety in C++. In C++, how many people love C++ here? No, no one. I knew that. Anyhow, but C++ is still dominant in audio field, and it's actually driving the innovation in C++. And the reason why is that C++ is one of very few real-time safe languages that we could use in audio field. And there are plenty of existing high quality libraries such as Juice, or recently some library called Chalk or whatever. There are many existing libraries that those C++ developers cannot leave. And real-time safety is really, really hard topic to, hard issue, a problem to achieve and to solve, because you have to follow the following three principles: no allocations, no locks, and no time unknown computations. So you cannot really depend on garbage collections, and you can't use mutex. Even try locks are not usable, and time-bound computations like JIT compilation on the fly is not really doable in audio. So since this real-time processing stuff is really hard to achieve, and we can't really do everything in real-time manner, we have to isolate those real-time tasks into audio thread, and everything else goes into non-real-time threads such as GUI thread or file IO thread or network thread or whatsoever. And then we have two different worlds, and we have to communicate with each other. Use, for example, loading sampling file and then passing that to audio thread, and it's gonna be it's called concurrency management, concurrent programming, and you have to deal with it. And it's especially in real-time manner, it's kind of difficult. And there are many good resources. I mean, maybe not many. There are a few great resources to have a look at, to understand and learn what the problems are. And real-time audio programming 101 is really a great, classic, authoritative material to read. And there's also a good good material called Real-Time 101 video on YouTube from Audio Developer Conference from in London, 2019. It is a really good video, but it has like 2 hours video, so it takes some hours to understand, watch and understand. But it's a great resource, and they discuss things like atomics and lock-free FIFOs and data queues. And some interesting recent trend is that people are actually trying to challenge those principles I mentioned: no allocations, no locks things. And first thing is that what if we could allocate memory on real-time threads? That's going to be interesting and useful. And there are actually standards called PMR, pre-allocated memory resources whatsoever, and it makes it possible to dynamically allocate memory. I mean, it just reuses pre-allocated memory, and just when malloc is called, it just uses this pre-allocated memory. So there's no actual allocation on the fly. So it would make things easier. And there another interesting move is that in audio threads, there's no way to use shared pointers using atomic operations, and it is regarded as impossible now in the past. And but people are trying to somehow implement it in highly technological way, and it is called atomic shared pointers. And there are some discussions that mentions this stuff. And the related topic is like deferred reclamation, which is basically garbage collection in lock-free manner. It is an interesting trend that happens in audio world. And then there's a Hazel pointer specification draft ongoing to be included in C# C++26, hopefully. They are very hot topics in this world. Anyhow, next, AI utilization. There are many usage scenarios that is related to AI utilization. For text description to song is very popular. Like you probably you have heard of Snow AI or Audio or music effects that can translate your text description to some song file. Another usage is complementary track making by AI. For example, recent Logic Pro introduced a feature for session guitarists and session drummers as well. And vocal synthesizers are really hot topic in AI related to music technology stuff. Synthesizer V, Vocaloid AI, Neutrino, VoiceVox. Sorry, they are all CJK related ones, but I'm sure that there are many English or European language based stuff as well. And audio source separation is another interesting topic that happens there, and assisted by your AI as well, which is like you have some complete song and that can be split into vocal track, guitar track, drum track, bass track, whatsoever. And there are some softwares that makes it happen. And pitch detection. Once you got those individual track like guitar track, bass track, and that could be interpreted and translated into some play notes instructions such as MIDI notes. And it is also helped by your AI as well. And AI mastering has been there forever. Like you have heard of Isotope products like Ozone, Elements, RX, whatsoever. They are also using AI technology as well. And there are people who applies this technology in audio plugins as well. And when we deal with AI model processing runtimes, I mean, people don't really implement something to train the data in audio products yet, but they would rather embed those train the AI models and embed it into the application with AI model runtimes. AI model is actually a set of mathematical functions, so they have to be translated to CPU instructions at some stage. And the runtime works just like a JIT compiler. And TensorFlow, TF-Lite, and Onyx runtimes are their example of those technologies. And especially when we are using Onyx, it would have to be compiled into some runtime model first, and then the runtime itself is also embedded into the final application. And music applications, especially audio plugins, tend to be like packaged into just one single binary executable library. So it is a little bit annoying to compile and bundle everything together for every platform. So there's a project called ORT Builder that helps make it possible, easier. And usually when we deal with AI stuff, we don't really have to do that thing in real-time manner. So it's just like loading file and saving file and dispatching data with the audio thread. But sometimes we have to deal with those AI inference tasks within the real-time thread. Like you are building some effectors and that makes use of AI training the models. You need some real-time models. And there's a project called Neural that makes it possible. And it has somehow shrink the data mathematical models that makes it possible to runtime in real-time manner. So it would be useful for some projects. And there are some existing projects called BYOD, Guitar ML, and Neural Node, and G-Rainbow. They are all using this Neural technology to make it usable in real-time manner in audio plugins. Sorry, this doesn't work. Excuse me. I hate it. Damn. Okay. Next is WebView as app UI, especially on audio plugins. Dealing with GUI in C++ is particularly annoying and they tend to be immature compared to other platforms because, say, can you name any C++ GUI framework that works everywhere and that supports hot reloading? It's difficult because C++ application tends to be like compiled statically and everything has to be compiled as an application. It makes it hard to hot reload everything. And that supports CJK inputs and rendering. It's particularly difficult. Like if you ever used Juice, you would have noticed that just that didn't render bold characters in CJK fonts. Or it still doesn't support Linux input methods on Linux. And the support for accessibility tends to be missing in C++ minor GUI frameworks as well. And basic widgets or even basic layout rendering engines also tend to be missing. And if we use WebUI, all those issues are gone. So people like me who want to avoid this kind of annoyance tend to use WebView. But if you're using WebView, there's a handful of problems to deal with. The first thing is data control flow, because now obviously we have JavaScript world and the C++ world, and they have to interact the data each other, just like audio thread and non-audio thread. And then especially it has to be done in performant manner. Like say you have to pass the audio data, I mean raw or PCM data into the web UI to render some equalized results on as a waveform. And I don't think I have ever seen anyone else who did that before. And bundling WebView 2 DLL on Windows is a particularly annoying topic, because audio developers tend to bundle everything into a single binary, and WebView 2 has to be installed separately, and those audio people kind of try hard to make it possible to bundle it. Even a library called Chalk compiles converts that WebView 2 DLL into base 64 binary and stores the string and put it on a header file. It's an extreme case, but people do that. And it also involves build complication, because now that we have JavaScript layer to build and C++ layer to build and bundle together into the application. So it's way more complicated than just building C++ projects. And since they are complicated and it's not very performant, maybe you would get potentially controversial reactions like, why do you want to use WebView? I would stick to C++. And this actually happens in JUICE community these years. And it's kind of interesting, but we have to deal with that. And oops. So, okay. Next. So I actually created a demonstration of WebView UI that tries to make it render the 3D waveform view. The left this thing. The left most left top window renders some WebView along with input from keyboard. So it's technically doable, I think, and I put this demo from on GitHub, and it is based on another WebView-based project called WeQ8, WEQ8. So at least it would be possible. Oops. Okay, next. Down. Next, let me talk about audio plugin formats in 2024. And there are still many plugin formats that we would discuss. VST2 is almost killed by Steinberg itself in 2018, so many years ago. But some people still use it. And VST3 is dominant on Windows, I think. And everything is different on Apple. Basically, AUV2 is the primary format on Mac OS, and there are VST3 formats there as well. But those VST3 works as an internally works as an audio unit. So technically, AUV2 is everything. But well, and there is another audio unit format version 3, AUV3, that runs on iOS. And it is totally different beast. Like you have to deal with the containerized process models, and it kind of brings performance problem. And people don't really welcome AUV2, V3 on desktop. So people tend to use AUV2 on desktop even now. And LV2 on Linux has not changed a lot, but except that it is expanded to be used outside Linux. I mean, the plugin for development tool called JUICE started supporting LV2 since version 7 last year, I guess. And then Reaper started supporting LV2 as well. So it's expanding the platforms, but the adoption is moderately increasing. There's a reason that there's another competing plugin format called Clap from Bitwig, and it emerged 2 years ago, and then it is released with a license called ISC, and then it has proper MIDI support. So it's probably the brightest hope so far. And so in 2024, we still have to release all those audio plugins in many formats still. Like, say, the reason is that Cubase, as measured DAW, will never support Clap because it's from competitor. And the VST3 has similar problem because Apple would never support VST3, and even Bitwig Studio wouldn't never support LV2 either. So they are biting each other kind of. So they would not be one single format to rule all. And traditionally, we use some cross-platform, multi-format SDKs like Juice or DPF or iPlug2 to build audio plugins. But some people at Clap has been trying to change the world of this, saying like, what if we just build one Clap plugin and use plugin wrappers to everywhere else, like say VST wrapper or AU wrapper, and they didn't even mention but LV2 wrapper whatsoever, and that would simplify plugin development. So they actually built a project called Clap Wrapper to make it possible. And if that succeeds and people find Clap as a great format to code with, maybe it would ease the plugin development. And especially with licensing, like there's no need to use VST GPL license stuff anymore, except for the VST3 SDK. That means like people don't use Juice anymore, but it's just one aspect, and Juice has a lot of other more features, so people would still use it, but the site might change at some stage, not now. There's some projects called like C Major audio programming language started supporting Clap output directly, so that if it happens, then there's no need to license stuff anymore. Okay, last MIDI 2 MIDI 2 adoption didn't happen a lot, and the reason, well, first of all, MIDI 2 had revamped last year. The specification from 2020 is gone, and it is altered by the newer specification that was released last year. And many platforms actually started supporting it. For example, Linux added support for MIDI 2 in Linux 1.2.10. Also 1.2.10. And Android 13 started supporting USB, and Android 15, which is going to be finalized this month, I guess, supported virtual MIDI 2.0 synthesizers as well. And everyone else is waiting for Microsoft MIDI Windows to complete that work. And Microsoft has been actively working on it, but it wouldn't happen until the end of this year. So anything related to MIDI 2 will happen next year, I guess, even including Web MIDI 2. Oops. And the hot topic here would be the use of MIDI 2.0 messages in audio plugin API. Like, say, when we build audio plugins that takes MIDI inputs and audio inputs, they would be like, say, if you build some audio process function that takes audio inputs and MIDI inputs and generate audio outputs, then MIDI inputs should be like would be still MIDI 1.0 based messages. But what if we could use UMPs, MIDI to UMPs directly? It would give much more fine data and refined data inputs from here. And then it would be useful. And Audio Unit V2 and V3 already support MIDI 2 protocols, so they are good students. And the CLAP also supports MIDI 2 events. And interestingly, they don't really endorse MIDI 2 events. They prefer supporting using CLAP events directly. But anyhow, it supports it. And VST3 is complicated. Like the VST3 team claims that it supports MIDI 2 because you can map any of those MIDI 2 input messages to VST3 events, so we already support it. But the way how they support MIDI inputs is not really welcomed by audio plugin developers. And there's a long thread on VST3 forums that people complain about that. And LV2 doesn't really mention anything about MIDI 2 yet, and I think it's because they could use any format in any event format in any URI, but in my opinion, they need some standardized message support, just like they have for MIDI 1. And Juice, the audio plugin development framework, started considering support it in the next version, but they just released the latest version last month, so it wouldn't happen until next year, I guess. So it takes a while. MIDI CI has interesting features a lot, but I don't think it's too much. It's widely used yet, but it has a lot of interesting features that could replace the audio plugin features, like saving and loading states and setting parameters, giving parameter list or program list or whatsoever. And they have interesting features, and they could replace some audio plugin features at some stage. So I have some interest in those features. Okay. There was a lot of discussion, superficial topics about that, all those audio related topics. So that's all so far from me today. So there are many things that I have talked. So any of those would have interested, if any of those had interested you, I would be happy. And I will be hanging around this area. So after the session, if you have any questions, anything you want to talk, please catch me up and throw your Pokeball here and to catch me and shoot any questions whatsoever. Thank you so much.
Thank you. So we can have a short Q&A. Any question? One or two. Sting.
Have you ever used game engine for UI? Like I've seen people using some game engine.
Sorry, which engine?
Godot engine.
Godot.
Yeah,
Not
yeah,
yet, sorry. But it would be interesting to integrate that those audio plugin, audio API stuff in Godot, I guess. Just like, say, Unreal has some dedicated engine and Unity as well. So maybe Godot would have something else, something similar, I guess.
Godot works with C++ really well because it has a dedicated extension interface for using custom C++ class. It can be registered directly into the engine code.
Okay.
So I think Godot would be easier to be used as a UI framework for audio plugin.
Yeah, I think that some people dreamed about that when dealing with Unity. Like Unity used to be regarded as a great tool to build some UI stuff as well, and using some audio in the background. And maybe the same would happen with Godot as well.